I joined HuggingFace about a month ago. For many of you probably are aware of, right? It's kind of a leader in the space around natural language processing and helping people build models. And I was like, I could do a tutorial on this. And they were like, no, no, if that's something that's online that people can go and kind of just follow along, let's kind of make it a little bit more interesting and share some of your experiences. And so I've only been with Hugging Face a month, but I thought I would share a few of the different kind of projects that I've seen and some of the things that excites me, and as well some of the things that are a little bit scary inside. So I'm hoping to share those stories. I think they have a nice technical bent, and we can learn a bit from them as well. Um, Feel free to ask questions during it. I will save time at the end for questions, and I'm also planning to kind of go to the breakout room for a little while. I'm in a hot room here in Chicago, so if I start sweating, don't be surprised, but trying to keep the fans off so you can hear me well. All right, let's jump into this. There's three kind of projects that I've run across since I've been at Hugging Face that I wanted to talk about. The first is the Big Science Initiative, which is a team of researchers building large-scale language models. The second is something that happened this last month, where we had a kind of a researcher, YouTuber, want to publish a model that was developed around hate. And that kind of stretched the boundaries and kind of had us thinking a little bit on the feet, and wanted to share kind of right some of the things that can go, that some of the bad things you can do with models. And then I want to end, and hopefully all of you already know about this, and this is old news to you, but just spend a few minutes talking about Dall-e Mini and kind of all the cool things we can do with that kind of generative thing, and all the different effects that's having. And if people have different ones that they have, it'd be great to kind of share that along as well. So let's start with talking about modeling. And it's hard for me to know kind of what everybody's background is here. So I'm going to do a quick kind of from 0 to 60 here very quickly on kind of large language models and get everybody up to speed. So at the beginning, kind of when we think about modeling, we'll start by working with data. And a common thing you might do is, for example, if you're trying to find out the sales price of houses, you might just make a simple visual. And this is how I think about modeling in my head, where I just write down what's the square footage of a house, what's the associated price. And you go out in the neighborhood and you collect a bunch of these. And as you start building this, you start seeing that there's some kind of relationship here, right? You can see there's kind of, very small houses here, but they kind of differ in their price. You have some very large houses over here, right, that are much higher. You can kind of start to see a relationship here. And at the essence, this is what machine learning is about, is helping us identify these relationships or patterns in the data to build a model. And I work with lots of different models in healthcare, telecommunications, but this is the mental picture I always have in my head for when I'm thinking about a model. Is you just have a lot of data, and we're trying to do our best to just identify and figure out what that relationship is in a very simplified way. Now, when we do this in the simplified way, of course, there's going to be lots of errors over here. That's okay. But that blue line there is a model. And the value of the model is forward-looking, because once I have this model, if somebody comes up and shows me, hey, I have a new house at this square footage, I'm able to predict what's the likelihood of the sales price. And this is why we use machine learning kind of everywhere to kind of ease these kinds of decisions. So this is kind of very traditional machine learning. But there's been some changes in the last 5 or 10 years that I want to kind of get people up through too. I'm giving my own biased history here. Other people could read it differently, but this is in my experience over the last 10 years, kind of working in machine learning. So for me, a pivotal point was what's known as this ImageNet challenge. And the ImageNet challenge happened in computer vision, where the goal was to build a very good model, but across 1,000 different object classes. So here you can see 1,000 different categories. You can see some of them expressed here. And the data for this provided was over 1 million images. So there's lots of images to process into these 1,000 classes. This is a very challenging problem, and it took quite a bit of while and right, many iterations for people to kind of figure out how best to build the model. But the final model that was built was actually a very large neural network. But one of the interesting things that they found is you have this very large model that's great at these 1,000 classes that we trained on in ImageNet. But actually, a big part of this model is what you could almost think of as pre-processing, just different ways to go from learning how shapes are to learning to identify an image. And we can actually take that information from the model that's been trained on ImageNet and transfer it to a different task. So in this case, you'll see down here, for example, as you see ships on the bottom. Maybe there was no ships in the original ImageNet, but a great part of that model that was trained on ImageNet, we can bring that through, do a little bit of light training kind of on this like custom top layers. Don't worry about that. But we can essentially transfer this to another task. And this has been a pivotal change in machine learning in the last few years. And sometimes it's called transfer learning, where we can take a model that's been trained for one task and use parts of it to solve for another task. And this is much better than the old days where we had to just train a model for every task. Because literally in the old days, the blueprint was always like, hey, if you want a model for that, go out and get a data set for that if you want to solve that problem. But now with knowledge transfer, it actually allows us to use some of the existing knowledge to quickly build a model, sometimes without even labeling, on a new problem. All right, I hate not being able to see faces. Hopefully this is tracking okay. So this idea of transfer learning has taken over in computer vision, natural language, audio. So for example, natural language processing kind of text studies here. There's often people that will take huge amounts of data, lots of compute, and build a very good large scale pre-trained model. And once we have that that's been trained like that, we can then reuse that large model and what's called fine tuning, just tweak that for other tasks that original model wasn't there to learn. And this has been a very successful paradigm in natural language processing. And a lot of the things that you see, I do TikTok, I see the little captions that come up, like all those little technologies where you start seeing a lot of speech and text kind of online, the auto completes are because of this transfer learning approach. And it's been kind of a revolution in terms of all of this. Now, if you're a modeler and you want to do this stuff, BERT might be one of the models that you've heard of. It's probably the most common one in this kind of paradigm of language models. But as soon as you start digging in, there's a ton of different models, right? Researchers like going in, building new models for other edge cases, for building better performing models as well. And so there's a ton of different types of models for these use cases. But the challenge is as they're building these large scale models, these models are getting bigger and bigger and taking literally months of GPU time to train. Where we've gotten to the point where to build some of these models literally takes millions of dollars of compute. So if you think about this, right, if you're spending millions of dollars of compute, right, this isn't something you and your buddies are going to be able to build, right? This is a major investment for an organization to be able to train one of these large language models. And one of the things that's happened is if we look at inside the industry right now at the largest scale models, so this is like 100 billion parameters and up, they're not open to the public. They're all closed access. So if we look at companies like Anthropic, AI, OpenAI, all of these have built these large scale models, but they've not given people access to them. And in fact, this is a well-known issue. Yesterday, as I was kind of putting this together, I saw this tweet that went by that looked at in the graph here, you can see, what has been the influence of academia on large scale AI? What percentage of results of that? And you can see historically, academia has participated a lot in large scale AI. But over the last 10 years, and especially the last few years, it's harder for example, for academics and researchers to be able to get access to those as some of the large, companies have access to that and get to decide who has access to that. So, and this is right. This is a bit of a problem, and you can start thinking about how what should we do to solve this? And there's probably many ways to think about solving this. One thing some academics here's my boiler point of all the issues. Um, to get specific on kind of some of the issues around this is the academics here didn't have access to kind of training data, training artifacts around that. A lot of the large scale models are either English or Chinese, not covering kind of all the other languages that are out there. There's a whole environmental cost to all these companies building these large scale models because they take a huge amount of energy, right? What's the carbon footprint? Are we kind of transparent about what the environmental cost is as we kind of decide to train our own large language model instead of sharing, for example? And then we'll spend a bunch of time on this as well, right? What about issues of bias, ethics involved in this, right? Hopefully, all of you are quite aware of kind of the stereotypes and the representative issues that happen with these models, and we'll spend a bit more on this as well. And so, right, what should we do? Should we just throw our hands up and give up? Maybe do a petition, right? Ask for access. Well, some academics, thought about it and they said, hey, if we look over in physics, physics has figured out how to solve this problem. They build kind of very large scale infrastructure that they collectively use for fundamental research. So the Large Hadron Collider is an example of this, where there's 10,000 researchers from 100 companies. Right, there's lots of fundamental discoveries that have happened from it. I think I was just looking at the newspaper yesterday. They were just showing somebody bicycling down in CERN, right, as they're setting up and getting ready for another run of this. So the question the AI community had is, can we build something similar within AI to do research? And there were some people that rose their hands and said, yes, let's do this. And together they've kind of built this, what I'm going to call this big science group that has over 1,000 people have joined it, 300 contributors. You can look at the map and see, what large parts of the world are represented here. It's divided up into about 30 different working groups. So you can see kind of some of the topics of the working groups as I put on my glasses to kind of read the topics, whether it's around kind of the carbon footprint, interpretability, evaluation, kind of few shot generalization, kind of many different topics like that. And so what this group is doing is they're going to take advantage of, I don't know how to say this. The French government has donated their supercomputer, right? So several hundred NVIDIA A100 GPUs to build a large-scale model. And this large-scale model is going to take several months to build. It's kind of 1.2 GPU hours. Now, where I come in and where I see this is HuggingFace is helping out with the organization, the storage of the model weights, as well. And so I've been just kind of a witness on the bystand to kind of see this project as it goes. And the goal is to build what they've named as Bloom, is a big science language, open source, open access, multilingual model that takes into account environmental concerns. The goal is to kind of build it in a very green way, considering ethical concerns, language diversity. I think there's about 46 different languages that are going to be involved in this model. So you can see this is one of the large scale model, 176 billion parameters that are there. 300 billion words, right? That's like incomprehensible. If you're curious about this model, it's been going along. They've been building it. It's taken several months to build it. They're getting close. It looks like at the kind of current track, they're going to be on track for figuring it out at the end of this month, hopefully. If you're all interested in large scale models, if you want to see how it's built, The Big Science Research Workshop has been very transparent on how they're building it, the various issues, kind of the logs that they have. So if you're kind of interested in, or if you're working in an organization that's building large scale models, it's a very interesting task. It'll also be very useful for the academics types that want to be able to research and experiment with the large scale model. If you want to learn more, check out the Twitter here, Big Science W. They have a feed, continuous updates all the time. You can also check out the progress on Hugging Face sites. The Big Science has an organization kind of where they publish their logs as well. So this has given you a taste of building a large scale model and how we might do that for academia. But academics aren't the only ones that are building kind of these types of models. But before I kind of jump into who's building them, let's remember these large scale models, right? That 300 billion words comes from somewhere. And a lot of it, frankly, is just the internet is being used. There's some sources you can see, like books, that are used, but a lot of the kind of the knowledge that's encoded in these large scale language models comes from just common crawling the internet web pages. Right? And if you spent a lot of time on the internet, you might be like, really? That's what they're using? Well, right, it's a good source of language, but if you think about it, right, there's probably a lot of biases. It probably doesn't necessarily represent what we all want to become. I'm hoping most people are familiar with kind of the basics here, where we know that many of these models just, right, they're trained on this historical past. Some of these groups, they're for example, are kind of news groups, the adolescent groups, or people acting like adolescents, right? The hate groups, very politically extreme groups. All that stuff gets fed into these large scale models, and so we've seen, hopefully you're aware of, right, these kind of common prompts that you do where, right, the models assume doctors are male, for example. In fact, I think I saw this one yesterday as I was putting together this, and this is with Dall-E, but you can see when you type in the idea of, hey, give me an image of a genius scientist. Well, right, what do we see? We see kind of all largely men here. So, stepping back, this is some of the issues we know with these models is if we start using them, they might carry with them those kind of past considerations. And we don't, right? We're not happy with that. We know that they can be used um, in ways that we don't like. So what should we do, right, if these models don't do things? And we'll talk about a number of different ways to do it. One of the organizations, OpenAI, that's developed models, has decided, well, we're not just going to put our model out there for anybody to use in any way. Like, we really see the problems that can be used with these models, because it's important to recognize these large scale models have a lot of uses. And one of the biggest uses is generating text. So if we can think about building kind of various spam bots, various communication bots, these things can run, right? You just feed them a little bit of CPU current, and they just run and run and run and can generate tons of content. And the scary thing is, right, as these language models get better, it's harder for humans to tell if this was a human that wrote it or if it was a bot that wrote it. So there's a lot of concern about the potential misuse of these technologies that come out. And so one approach that OpenAI has taken is that, we're not going to put our model out there. We're not going to just give that. We'll give people access. We'll build an API, right? And then you can, right, if you pay enough money, you can use the API. If you're a select group of researchers, you can go in and use the API as well. So, that's one approach to doing it, because, like I said, again, they're worried that somebody's going to identify some flaw in their model and they want to be able to kind of fix it and keep it under their control as well. But not everybody's like that. There's been other organizations that have built out language models. And kind of one of the more notorious things that happened in the last few weeks while I was at Hugging Face was this guy, and I hate to give him more publicity, but Yannick, who's kind of an AI researcher slash YouTube, decided to take one of the large scale language models and do what we called earlier, kind of fine tune this a little bit, and to teach it one particular way of talking. And the way he chose was kind of using 4chan, which, if you're not familiar with 4chan, it's I don't know, it's a discussion group, but it really just rhymes on kind of extremism and hate and kind of being politically incorrect, like that. Revive around kind of just being awful kind of speech. And so this was obviously kind of, in my view, kind of a publicity stunt by Yannick, just, very kind of adolescent, just looking for attention by taking something that was like the most repugnant thing and let's build a model on this and kind of get some attention. And this is the thing with these language models as they grow in power. Um, as they grow in power, well, hold on, there's two different things. So one thing is with the language models is as we get more and more computing resources, as we get bigger data sets, anybody can build a better and better model around this. But then also we have to decide how we want to use these models. Like, right, what are the rules should be for appropriate use? And you can see at this point, a lot of the leading AI companies have been very restricted because they're quite worried, right? If horrible things go wrong, it might come back to them. The impacts could be potential regulation as well. Now, so Yannick took this model, he built it, and he talked to HuggingFace before he did this. HuggingFace is a place where the AI community shares their models, shares data sets, other pieces too, but has hosted lots of large-scale models for a long time. And so he wanted to put his model on kind of HuggingFace. And and again, like, I was largely a spectator in this, but right, you can see the internal discussion of, right, this is a model that, maybe it has a little bit of narrow research purpose of it, like solved a particular benchmark, but really all it does is just verbalize hate. You give it a phrase, it comes back with something hateful. Right. On the other hand, right, Hugging Face is a place for the community, for people to share. Don't want to get into kind of saying what, policing what's on there and what isn't on there. And so you can watch it, you can go and check out and follow this debate yourselves. This is one of the kind of the model pages here. Is the model by Yannick was placed on there. The model weights originally were available for everybody. But then after finding out like how he had used them for like doing bots and kind of testing them on people and some of the other, it was decided to kind of restrict access to it. So take away kind of public access to the model. I wasn't kind of involved in deep in the discussions, but the great thing is you'll see here, there's a nice community tab where anybody can participate. And there's a number of people that participated, but Hugging Face has also shared kind of what their thinking was inside in doing this as well. So for those of you kind of interested in these kinds of controversies and this back and forth, this is kind of a great, interesting kind of use case story. But right, it just shows us, right, the boundaries of these models when they can be used for harm. Okay, I have one last thing I want to talk about and kind of close into wrapping up here. I want to spend a few minutes talking about Dall-e Mini, and this is where I wish I could like see your faces and get your hands raised so I know how many of you are familiar. I'm hoping most of you are familiar. If not, right, you can type this into Google while I'm talking and be able to kind of pull it up and play with it. But Dall-e Mini is a way where if you type in a little bit of text, it will automatically generate an image that matches the text. And the great thing is here is your text can have different types of imagery, different types of sayings, and it will do its best to try to build an image in that take. And I've seen so much good stuff, and I almost wanted to fill this presentation, but I think easily if you could do a quick Google search or even YouTube, Twitter, like everybody's full of these examples to do that. But let me give you a little bit of back history on this, and then we'll get to kind of the questions and we can talk a little bit more about all this. So Dall-e comes from, originally there was a model called Dall-e. Last year, OpenAI released Dall-e 2 that can kind of create these realistic images from a text description. And just amazing stuff that can. Now, OpenAI, when we talk about Dall-e, decided to keep it, the Dall-e 2. I don't know about the original Dall-e, but the Dall-e 2 has decided that only them and their researchers are getting access to it at this current point. And this is when another person named Boris here, and I have his GitHub here, decided, hey, well, I can't get access to Dall-e. Why don't I just build my own? Now, the original model had, I think it was on the order of, weeks of computation to build. But kind of Boris took some time, thought about it some little bit, figured out some ways he could cut some corners, did things like, make the resolution size smaller, and was able to build a model that could train in about 3 days, I think was the final model. And you can go grab his code, grab all of this out there. And largely, right, this was the pushback because he couldn't use the Dall-e. So he's like, I'm going to go create my own like that. You can see over the last couple of weeks that this has grown. He has a ton of stars, a ton like that. And once he had this model, he put it out there on, again, the HuggingFace, the hub here, of being able to kind of share that out. So this is kind of what we call spaces. This is a kind of where we have simple hosted applications inside HuggingFace. And this is a simple app for those of you trying this out, where you can kind of run any of your machine learning code, wrap it in a Streamlit or Gradio, and build a little bit of an app. And he built an app, or the community, I don't know exactly if it was Boris or who built the app, but we built the app. And I think the app was actually built several months ago. And it wasn't until kind of a big Twitch, I think it had slowly grown in popularity. And about a week and a half ago, I think a big Twitch streamer got on it and played around with it and shared it on his Twitch stream. And that's when like one of my kids told me, like, hey, what's this like HuggingFace thing that you work at? Like, he finally figured out like the company that I worked at from seeing the demo on a Twitch stream. And I was like, yeah, no, that's what, that's part of what HuggingFace does. The small part is host this machine learning apps. Well, in the last week and a half, 2 weeks, this has kind of blown up tremendously. And like the port infrastructure people on ours, and I think a lot of this is actually hosted by Google, the compute on the Dall-e side. But they've had to keep turning servers on, and they still can't turn off enough servers, because I think at one point we went from like 100,000 users a month to like 2 million in a day. It's just a crazy amount of traffic as it went kind of viral. And I know, like, for those of you who run it, like, I get it. Like, you hit run and it says it's overloaded. Just play it like a video game. Keep pressing run over and over again, and it'll go. And it takes like about 2 minutes of compute to get to the final images as well. And I can tell you, kind of from my own personal experience, like, this has been awesome. Like, it's been a ton of fun, kind of looking at all these images, and it's a great example of kind of the creativity of people and kind of pulling these together. And on a personal basis, like this has been an introduction to AI for my family. This is like screenshots from my family group chat, where like everybody was like sharing the images that they built on Dall-e as well. So it's a pretty cool kind of thing. And it's a nice way for the folks that are a little less knowledgeable about AI to start understanding a bit more about them. Okay, this was on the quicker side, because again, I like kind of interacting and talking with all of you. Hopefully, gave you a little bit to work with in terms of thinking and knowing about a large scale language model. If you're interested in kind of all of that, again, go grab the details. But also, so we can talk about the implications, right? What are we going to do with these models, right? Like, people can use them for nefarious purposes, right? Like, we can control it as best we can, but how are we going to kind of limit that? But also, right, there's also an upper limit and just really almost a new form of creativity that we can happen kind of with these large scale models. And I ducked the whole like Google sentient lambda thing as well that I saw this week as well. But that was outside of HuggingFace, so I didn't feel like I needed to talk about that. All right. Well, thank you all. I'll go ahead and like hold here and see kind of what other questions there are. Hopefully I'm within kind of the time ranges here.
Hi, Rajiv.
Yes.
Okay, you can hear me. We're good on the time range. Thanks for your talk. We have a bunch of questions here in chat. And the first one is from our beloved Shoop. What do you think of the mainstream viral hit of Dall-e and Dall-e Mini on Twitter and social media in general?
Yeah, I mean, I think it's the coolest thing. And I think I think there's several things about Dolly 2 that I think. So one is there's a new form of thinking you have to do, and I could see this in my own family because right the essence of creating a funny Dolly image is like taking two concepts that don't necessarily fit together but finding a way to fit for them to fit together in a visual way, right? Those are the most striking images that came. And like my wife kind of struggled, like she wasn't creative enough. Like she's an artist, but she wasn't creative enough in the text way to kind of build those out. So I think one is just the creative thinking that goes on. The second is this is a great introduction for folks that don't know much about AI, large scale language models, image generation to start understanding what are the possibilities of AI, right? Like as AI machine learning, we're often our own little community where we kind of like just sit in Google Colab and like build things, but like it's hard for like everyday people to understand kind of what we're building and the implications of this. And this is a great example of the idea of being able to turn our text, our images into bits, be able to arrange them in new ways, kind of build pictures from them. And then finally, and I don't know if this is the good or bad, but it's the right. It's just the story of it is like that historical evolution between kind of taking a model like Dolly and deciding to kind of fence it off from someone else. And then, someone like Boris comes along and decides, hey, I'm going to build my own version. It's not going to be as great. It's going to be kind of a slimmed down in some ways. But in essence, if you look now at the Google results, like it's overtaken Dolly in the Google ranks, and it's become kind of much more influential, in this kind of viral space that we're living at right now than the original Dolly, just simply because it is more accessible and people can start using it right away as well. So yeah, a lot of good stuff. Thanks, Hugo.
Yeah, definitely. You mentioned quite an interesting thing, like so your wife is an artist, and given that Dall-E generates, can generate these futuristic things, what are her thoughts on this? Like as an artist, what's the impact on art community, do you think?
Yeah, I don't think for her, she doesn't kind of do kind of the same kind of visual imagery art like that. So it isn't for that. I mean, there's been a lot of inventions that have helped kind of average people build and become more creative. And you still have professional artists, you still have professional photographers. So for me, this type of stuff always gets people more interested in doing more with it. And so I think in the end, it's kind of a rising tide that helps artists in general. I feel the same way as I did because, I'm older. I remember the days before we had kind of iPods and iTunes where it was so hard to have and carry and use music, and kind of the revolution now where everybody carries music with them. Similar things can be done for kind of the visual when we make it so easy to work with as well.
Got it. One question here from Olha. Do you think that these large and powerful models, should they be moderated or open sourced for all?
Yeah, I mean, I think everybody realizes the harm from them. And this is why you see the big companies kind of having them kind of putting tight restrictions around them because, in the environmental movement, I think there was it was kind of like the Silent Spring or kind of the Love Canal, right? There was certain episodes that happened in the environmental movement that showed how bad and how awful pollution was that led to regulation. And I think the companies are quite aware of historical pieces like that, so they don't want similar really bad occasions to happen with these large language models because then they will be put to restrictions. And there is a great deal of harm that can be done. I mean, this is where, HuggingFace is trying to kind of build these things in a very open way with the open source community, with the research community, so we can have a public discussion. We can get a lot more people looking at it versus being locked up in a private lab. And so, that's one of the reasons I'm excited about kind of what HuggingFace is kind of doing in that way. And hopefully that will help with some of these kind of questions and issues around this. But I mean, I can't answer that. I mean, it is something that I bet you if you watch your news, you'll see it go up and down, is how are we going to deal with these models? Because the other thing about them is they keep getting better. Like a lot of things when we build things kind of tail off, but the evidence right now is at this point, if you keep feeding them, the performance keeps getting
Mhm.
better. It's not kind of hit a point of really diminishing returns like that. So you're going to see a continued growth over the next few years, in this way.
You mentioned harm, and like the first thought I had after your presentation, like imagine someone combining the 4chan model and feeding all that input to Dall-e Mini. This can
Oh,
generate a lot of harm.
oh yeah. I mean, I'm
Yeah,
sure kind of between the 4chan and the Dolly, there's a lot of people and business ideas thinking about different ways that they can do this, whether for making money or creating hate or division and stuff. But yeah,
yeah.
absolutely. As these kind of approaches get out there, people will find ways to do it.
Good. Now maybe more on the infrastructure side. Like how did as Dall-e Mini got so uh, well known on Twitter. Like I used it a couple of weeks ago, and I was like, I wanted to try some Dall-e, but I couldn't get access to like the official API.
Mhm.
So I just Googled like Dall-e on your own or something like that. I ended
Yeah.
up. That's how I personally ended up learning about HuggingFace and about this Dall-e Mini app that was not so well known at the time. And now that over the last days, basically, you said that it grew to 2 million of viewers. Like, how is Hugging Face internally coping with that?
Yeah. I mean, it's literally the kind of, I think one of the ads, one of the little videos, that one of the people put on TikTok literally showed like servers on fire, and that's what it feels like. I mean,
Yeah,
they've been scrambling, right? Like anybody who's been in something like this, like you keep kind of putting things up. You try go back and kind of, if you look at the code, right, trying to figure out like how can they optimize the code a little bit better to show everything to cause a little bit less. And a big part of this though is, I think it should be given credit, is like, right, the Google kind of TPU research has been the one that's been doing the hosting of the actual Dall-e Mini app on their research arm like that, and so that's been instrumental. But yeah, they can't get enough servers to kind of keep up with the demand, and I'm hoping, like, after the big spike here, it'll kind of narrow down so kind of everybody can gradually use it on
yeah,
their own
yeah.
like that. Because my guess is if you found it a couple weeks ago, you were able to kind of use it without a lot of errors back then.
We've got quite a special question here, but
Mhm.
a very like interesting take on this. I think. Uh, can these models help us compress videos better? Like Bogdan asks specifically, when are we going to get 10 times more efficient video codecs?
Absolutely, they can. I mean, because at the end of the day, a lot of these kind of models, the way they're thinking about is they're building kind of some kind of very. I could think of it like a very. Your original video and all that information might be out here, but it's very condensed way. They're trying to understand, when you talk about an avocado, what's the essence of an avocado? How can I break down an avocado
Yeah,
into a small thing? How can I break down an armchair into just the essence of it? And that's right, in the Dall-e case, they're doing it. So a lot of these techniques, by kind of bringing and condensing these things down, yes, do touch on compression. And I think actually, there's been a lot of this research over the last couple of years has been used already to improve image editing, improving video editing along the way, as well as with compression. So, absolutely, absolutely, there's relationships there.
all right. I think we have time for a couple more questions. Like, what's your take on, are we getting closer to generic AI? Is it around the corner?
I don't even I see that stuff, like, I don't know about that. Like, I'm a practical guy. Like, I help like
Yeah, yeah,
companies,
yeah.
like, get subscribers, or like insurance companies figure out how to price cars. Like, I mean, that stuff is like way outside. It's
Yeah.
my thing, and kind of a more philosophical thing. I saw the recent thing with Google and the person who thought it was sentient. Like, this is stuff that I don't know. I deal with much more practical problems of like, hey, how can a company make a little bit of money and solve a problem with AI? And all that stuff is far away from that.
How do you think, like, have you heard anything about people actually using like Dall-e Mini or some of these large transformer models, like to, for business use cases? What are like the practical use cases that can these things power?
I mean, so there's lots of practical use cases from them,
Hmm.
because these large scale language models have a very good understanding of the language. So that means if you're building, for example, kind of some type of chatbot or something that interacts with people, it understands the synonyms. It understands like tall and short or opposite, or like tall and big and high, or can be related words. So the large scale models actually make it easier for building things like a Siri and Alexa and all those things where we interact with it, where the assumptions we expect humans to have when we're doing language, those large scale models can incorporate that. So on one side, kind of when we start talking about just language by itself, it just becomes much easier. And you'll see translation apps is another kind of common case where we can easily translate between multiple languages just using one model. Just crazy stuff like that. I can give more examples, but yeah, does that help a little bit?
Yeah, definitely. Like you mentioned, like these are very large models. And in terms of translation, especially from foreign languages, like my personal use case was usually when I was traveling somewhere.
Yeah.
And when you travel, maybe your phone is not, in roaming, so you can't really download the latest language model, or it's not like
Absolutely.
other ways to kind of minimize them and make sure that the mobile phone kind of runs without network connection.
And this is where we need a ton of software engineers, because with every decision around this, you have engineering trade-offs, right? Like, yes, you have a large language model that's like perfectly grammatically correct on things, but it takes like 45 minutes to get a prediction, right? Like, that's no good. Like, you need something that runs in a reasonable amount of time on your kind of handheld device. Well, right, you're going to have to make some simplifying engineering assumptions in order to speed that up. And so this is where kind of there's a ton of room for kind of engineering and software, for software engineers and other folks to kind of work is, yes, you can build these theoretical high things, but how can we rearrange and configure them to fit the systems and the other technologies that we want to use them? So yeah, I mean, and there's a whole, there's an Optimium package on Hugging Face that helps people do that. I mean, there's whole approaches like quantization and things that help people scale down models, and there's a science itself to kind of figuring out that as well.
Awesome. Thanks for sticking with us.
Yeah, this is fun.
This was fun. Like, I'm super excited that you have joined DevFest for Ukraine. I know that Rajiv will be available in the breakout rooms. So Rajiv, please join it on the Hopping platform. And the folks who've been tuning in, please feel free to join into breakout room as well and chat with Rajiv live. Rajiv, any last thoughts from you? What didn't we ask?
No, this was great, and I'm glad. The hate stuff, I'm glad we didn't ask a lot about, but I'm glad we focus on the joyful stuff instead. So I'm with you.
Yeah, we can leave Twitter for that. All right. Thanks, Rajiv. Thanks for tuning in.
Thank you. Thanks for having me.
Hope to talk to you later.
Yes. Okay.
Bye-bye.